So you can forget, well, I wouldn't say forget the first line. The first line is security environment. Always a good practice to start with that. And so X is the number of times per week a student eats out at a restaurant, and X is 1 through 5. And the next one amounts spent per week on food. And those are the values. Last time we did this using a TI-83 calculator. And what was the very first step that we did?
We input it there.
True, that's pretty much what I did. After we put the data in the calculator, what did we do? The very first step. Okay, prior to that, I said this has to be the very first step one has to do when they're trying to fit a regression model.
Graph the data.
Graph the data. And we use the scatter plot. So both of them are Harry, so the number of times a student eats out at a restaurant, followed by a Y labeled money spent. I'm going to graph this. That's what it looks like. Similar to the graph that we had. Yes. We can change the axes to get a better picture. How did we do the axis part or axis part in the calculator? Zoom start or Zoom 9 did one of those. It's exactly at 100. So that's the plot we get, and I noticed last time that I didn't mention anything. Do you think it's a perfect line? Perfect straight line? No. There is a slight curve to it. But regardless, I fit a linear regression model. Now, could we choose a different model? Absolutely. What other model do you believe would work for this? How about a nonlinear quadratic model? Would that work? A parabola has a curve to it. Yes. Exponential might work, but I don't think this stuff is exponential. So now that we have the graph, the next step is to fit the model. And easy and R. The name of the function is LM. If you have to take a guess as to what LM is, linear model, very good. Y variable regressed on X. So and that's the model I get. Coefficients intersect 41.2. I believe that's exactly what we had last time, or 41.19. And the slope is 11. So the coefficient of every predictor variable, in this case x, will be listed under its label. So here it's x, so we have 11. When I look at it, I can write the model as 41.2 plus 11 times x. Pretty straightforward. Good. How do we find the fitting value? I'm going to show this using the calculator as well. Before we get into that, what is a fitted value? The fitted values will follow the formula. For that to happen, we have to plug in the values in the formula. In R, things are a bit straightforward. If you want to find the fitted values, you can simply do mod dollar fitted values. So just going to access fitted values for you. Next step, I'm going to plot the line corresponding to the fitted values, or using the fitted values. And that's the line we get. Got pretty lucky. That's a very good start. Well, putting it lucky, I wrote it that way. The next step is to compute the residuals. What is the residual? So the residual is simply the difference between the actual value, in other words, the observed value for y, minus, or difference between the actual value and the fitted value. So actual values are y minus fitted values and those are the residuals. Yes? Now, What do we expect the sum of residuals to be?
0.
0. Let's see if we get 0. I get 7.105 times 10 raised to -15. That's not 0. Very close to 0. You cannot expect an exactly 0 value in linear regression because we are dealing with random data. So exactly 0 is unrealistic. So we get a value that is extremely close to 0, 7.105 times 10 raised to 15. Centroid is a fancy name. Might have heard of it in calculus 3. What is centroid? If it's just x bar, or if it's just y bar, we call it the mean, right? It's right in the middle, it's the center. But when you're looking at higher dimensions, more than 1, then you have a point, the coordinate pair, so that would become the central. We call it the central. Now, people who take computational technology with me should know this. Do we? Is anything coming back to me? Kind of? Okay. Kind of is better than no, I know nothing. So the centroid happens to be 3, 74.2. Ah, I see. So I saved it as a vector, but it's not. What can you say about the central and the regression line? Centroid falls on the regression line. In other words, the regression line passes through the centroid. So when you plug in 3, you have to get 74.2 the theoretical model. If you don't get it, then you made a mistake somewhere. I'm going to multiply x with all the residuals. So x times the residuals. Now I'm going to sum them all together. I get 3.55 times 10 raised 30, 14. So, in other words, what should the x values, predictor values, times the residual equal to? 0. We're not going to get exactly 0. We are going to get approximately 0. I'm going to take the fitted values, multiply by the residuals, so dot val times mod dot res. I get 5.96855 times 10 raised negative 13. So, in other words, what should we expect to get? 0. So, bunch of properties. The linear regression model has to pass through the centroid. If you multiply x by the residuals and sum them all together, that has to be 0. If you take the fitted values, multiply by the residuals, sum them all together, that has to be 0. And sum of all the residuals must be 0. Are we clear? Yes? Epsilon, I had the actual value minus fitted value. And specifically, it is the actual value minus the fitted value for y, not x. Good. The fitted line will pass through the centroid, x bar, comma, y bar. You take the fitted residuals, multiply by the x value, sum them, it has to equal to 0. Now, if the sample residuals are going to satisfy those properties by default, it implies that the original or the actual residuals will also follow the same properties. The only difference being if you take the exact residuals, you'll get 0. The approximate, the one that you get from the sample will be approximately 0, but very small, as I showed in R. I am going to put hat and simply equate the sum that I get from the sample to 0, very, very small, extremely small, in the order of 10 raised negative 15, etc. So I'll just call it 0. Are we clear? Yes?